The year is 2360, and Earth looks calm from orbit. Sunlight glints off long chains of orbital habitats circling the planet in silent lines. Huge mirrors hang in stable positions between Earth and the Sun, tilting just enough to cool overheated regions or warm frozen farmland. Thin sheets of artificial clouds drift over cities, guided by climate AIs that manage storms and rainfall with careful precision. On the night side, the darkness is broken not only by city lights but by moving bands of dim green and blue. These are the climate control grids, low-orbit satellites that stir the upper atmosphere, soften hurricanes, and bleed heat away from crowded megacities. At polar latitudes, shining towers on floating platforms pull carbon from the air and lock it into glassy black bricks, sinking them into the deep ocean. From far away, it looks like humanity has tamed the planet. Marcus Hayes knows better. He stands at the forward window of the orbital station Terra 9, watching the Indian Ocean slide beneath the station's path. He has seen the maps. He has seen the numbers. Earth still moves on its own terms. Marcus is a global tectonic cartographer. His work is to read the slow motions of the planet's crust the way meteorologists read clouds. He uses orbital sensors, deep ocean probes, and AI models to follow the movement of plates, faults, and mantle plumes. For most people, the ground is something solid. For Marcus, it is more like a slow, dangerous sea. He leans on the padded rail and zooms the glass overlay in front of him. The Indian Ocean fills his view, a wide blue hollow framed by Africa, India, Southeast Asia, and Australia. But over the water, faint lines appear, color-coded models of tectonic plates drifting against each other. A segmented orange shape lies in the center of the ocean. It looks like a broken continent, hidden under kilometers of water. Lemurian tectonic complex. The overlay label says, alive for at least 180 million years, forgotten for almost as long. The Lemurian Plate was first discovered in the late 2100s, when deep gravity surveys picked up a strange dense mass under the Indian Ocean. At first, scientists thought it was just a thick piece of old crust, left behind when the ancient supercontinent broke apart. The idea matched stories from the 19th and 20th centuries about a lost land called Lemuria, a place storytellers once imagined between India, Madagascar, and Australia. Most people laughed at the idea that the myth was real. The name stuck anyway. Throughout the 2200s, ships and drones mapped the seafloor above the Lemurian Plate. They found tall plateaus, flat plains buried in sediment, and a few steep ridges that looked like old mountain chains smoothed by time. Nothing about it seemed magical. It was just another old piece of crust, cracked and heavy, locked in place by the plates around it. For decades, Lemuria was a curiosity for geologists, and a nice story for travel documentaries. It was the ghost continent under the ocean, interesting but harmless. Then the anomalies began. On Marcus's screen, new data layers slide into view, tidal records, gravity fluctuations, seismic logs. Small numbers, quiet changes, spread across almost a century. Remembers the first time he saw them years ago, when he was still teaching part-time at the Nairobi Geoscience Institute. A student had come to him after class with a strange simulation. Dr. Hayes, the Indian Ocean tides are off, she had said, nervous but excited. Not much, just weird. At the time, Marcus had smiled and glanced at the model, expecting a simple calibration error. But the more he looked, the less he could explain it away. The anomalies were subtle, tides arriving just a few minutes early along the coasts of East Africa and Western Australia, then late along parts of India. The differences were tiny, measured in centimeters, yet too consistent to be noise. Oceanographers checked their models. Climate AIs recalculated the winds and currents. Nothing fit. Then came the gravity waves. Not gravitational waves from space, but soft, slow shifts in Earth's own gravity field measured by sensitive satellites. These waves took weeks to cross the ocean, rising and falling in smooth cycles, as if something heavy deep below was changing shape. The pattern did not match normal tectonic activity. There were no strong quakes, no sudden subduction events, just a long, slow swelling and relaxing of mass under the Indian Ocean. Breathing. An intern on Terra 9 had whispered when the first processed image came in. It had been a joke, but it stuck in Marcus's mind in a way he did not like. Then sonar scans began to show something new. The seafloor over Lemuria was not staying flat. The change was slight, just a few centimeters each year, but over an area bigger than India, that tiny rise spoke of enormous forces. Plateaus that had been stable for millions of years started to lift. Sediment layers shifted. Long, low ridges thickened, as if giant invisible fingers were pushing from below. What bothered Marcus most was not the rising itself, Plates rise and fall all the time, sliding over mantle currents. What bothered him was the rhythm. It did not look random. He flips through time-lapse imagery now, watching a century of data blur by. The Lemurian Plate seems to pulse upward, then hold, then rise again. Each surge lines up with those deep gravity waves, with tiny shifts in Earth's rotation, and with flickers in the planet's magnetic field. It looks like coordination. Behind Marcus, the doors to the observation deck slide open with a soft hiss. A woman steps in, her boots making almost no sound on the padded floor. "Always the Indian Ocean," she says. "Do you ever look at anything else, Marcus?" Marcus turns. Director Una Igarashi of the Global Tectonic Council stands there, hands tucked behind her back. Her hair is graying, her posture straight. She has the calm of someone used to managing disasters that most people never even hear about. "I look where the planet moves," Marcus replies. "Right now it's moving there." She joins him by the rail, eyes scanning the glowing overlays. "How bad?" she asks. Marcus hesitates. He still has a habit of softening his words. The last time he had said, "It might be bad," a minor quake had grown into a tsunami that took his wife and son with it. The models had underestimated the resonance of the waves in a narrow bay. The warning had been late by 7 minutes. 7 minutes that never left his mind. Now he no longer trusts gentle language. "The rise is accelerating," he says. "In the last 10 years, average uplift over the Lemurian Plate has doubled. Parts of the central plateau are climbing at nearly 4 centimeters a year." 4 centimeters. Una raises an eyebrow. "That doesn't sound like much." "It is when it covers 10 million square kilometers," Marcus answers. "That's 400 cubic kilometers of rock and sediment moving up every year. It changes ocean depth, currents, tides. It shifts Earth's moment of inertia." He points at a small graph on the edge of the display, a line tilting upward. "We're already picking up micro changes in day length. How much time do we have?" "I don't know." He hates saying that, but it is the truth. If the acceleration continues, in 20 years parts of Lemuria will be shallow enough to disturb major shipping lanes. In 50, some regions could be close to the surface. In a century, he exhales slowly. We might see new land breaking through. Una studies the display in silence. "New land," she says at last. "People have dreamed about Lemuria rising for centuries. They imagined new continents, new resources, new places to build. This isn't a dream," Marcus says. "It's a tectonic event on a planetary scale. Ports from Mombasa to Perth sit on coastlines that might twist. Undersea city nodes, fiber trunks, and power grids are anchored to that floor." He zooms in on a cluster of glowing icons off the coast of India. Deep-sea mining rigs, algae farms, gravity anchor cables for orbital towers. If the base shifts under them, they break. Una finishes quietly. Marcus nods. And that's the simple part. The harder part is this. He taps another control, and the overview of Lemuria changes. Heat maps appear, showing where the crust is warming from below. Thin curves show the paths of microquakes, too weak to be felt at the surface, but clear in the quantum seismic arrays buried in the seabed. "It's not rising like a normal plate," he says. "Look at the pattern of quakes. They're not scattered along a simple fault line. They form loops, clusters, repeating arcs." Una frowns. "Stress redistribution? That was my first thought," Marcus says. "But then we compared them to global background noise. The quakes line up with those gravity wave cycles. Each time the deep mass shifts, certain fault clusters activate in precise sequences. Like," he stops himself. He knows how he sounds when he says it out loud. "Like what?" Una presses. "Like ordered firing," Marcus says quietly. "Like a network." Una stares at him. "Marcus, you are suggesting that the Lemurian Plate is thinking." "I'm saying its activity looks structured," he answers carefully. "We're picking up regular humming vibrations in the 3 to 5 Hz range that don't match any known ocean, tectonic, or industrial source. The heat flow is patterned. It starts near these so-called neural hotspots." He points to glowing knots inside the plate, then spreads in waves that look like signal propagation. "Neural hotspots," Una repeats. "You're calling them that already." "Off the record," Marcus says. "Officially, they're anomalous seismic nodes." She gives him a dry look. "Anomalous seismic nodes that behave like brain regions." The analogy is weak, Marcus says, though he is not sure he believes his own caution. But the structure is real. When a hotspot activates, local uplift slows in some surrounding sectors and speeds up in others, like something is redirecting force, not just releasing stress. "Maybe the mantle flow changed," Una says. "Plume reorientation, new convection cells." "We modeled that with 6 different AI stacks," Marcus interrupts. "None of them reproduce the pattern without adding unphysical assumptions. The only way the models match the data is if we treat those hotspots as control centers. He zooms in on a region near the center of Lemuria. The crust there is thicker, cooler at the top, hotter at depth. Microquakes trace spirals, almost like arms reaching out. Something down there is organizing how this plate moves, he says. It isn't just drifting, it's acting. The word hangs in the air. Acting. He remembers another kind of acting. A normal day on the coast years ago. His son trying to skip stones. The first warning that came too late. The sirens. The wall of water that rose on the horizon where there should have been calm sea. The roar. The way the ground shook like a living thing in pain. Since then, whenever the planet moves, Marcus's chest tightens. His hands feel heavier. Sometimes he wakes from dreams where continents shift like shoulders and cities fall like loose skin. He forces the memories back and focuses on the data. So Una says finally, "What do you need?" More eyes, deeper sensors, faster models, Marcus says. A full task force. We can't treat this as a curiosity anymore. If Lemuria keeps rising, it will rewrite coastlines across 3 continents. Ports will deform. Submarine cables will snap. Tidal patterns will change in ways our climate systems weren't built to manage. And if this process is driven rather than random, Una nods slowly. We need to know what is driving it. And if we can talk to it, Marcus says, almost too quietly for her to hear. She glances at him. Talk to a tectonic plate? He shrugs, but his eyes stay on the glowing map. If this is just a natural anomaly, then we plan for impact and try to shield populations. But if it is something more, if this is a built system, a geo-engineered structure waking up, then it may respond to signals. It may listen. He does not say the word conscious. Not yet. It feels too large, too strange. Una turns away from the window and walks toward the door. All right, she says. You'll get your task force. I'll bring this to the Global Council and Planetary Defense Command. But Marcus? She pauses and looks back at him. Be careful how you phrase this. People are comfortable fighting storms and rocks. They are not comfortable with the idea that the ground might wake up. The ground is already waking up, Marcus says. Our comfort isn't part of the equation. She studies him for a moment, seeing the tightness in his jaw, the tension in his shoulders. You're too close to this, she says softly. I'm exactly as close as everyone else on this planet, he replies. We all stand on the same crust. The doors close behind her with a soft hiss. Marcus stays at the window a while longer, watching the silent blue surface of the Indian Ocean. Ships cut thin white lines across it. Floating farms ride the waves. A few new underwater habitats wink on the display, their life support systems drawing power from geothermal vents that rise out of the depths. All of them rest on the assumption that the seafloor is stable enough to build upon. Marcus knows how fragile that assumption is. His personal console buzzes. Incoming, International Lemurian Task Force briefing packet. He opens it. A list of names scrolls by. Tectonic engineers from Lagos, oceanographers from Chennai, quantum seismologists from Cape Town, AI modelers from Sao Paulo, orbital sensor specialists from the Pacific Ring habitats. Nations that once argued over borders have learned to cooperate in matters that threaten the whole planet. Lemuria for now belongs to everyone and no one. Attached to the briefing is a short message from Una. PDC AI has been notified. They will monitor your findings. Stay scientific. We are not at war with the planet. Not yet. Not yet. Marcus looks back at the image of Lemuria. The orange mass glows faintly under the ocean, its edges pressing against the familiar outlines of Africa, India, and Australia. Up here, it is just a shape on a screen. Down there, kilometers of rock and magma are shifting in silence. He calls up the latest quantum seismic feed. The familiar humming pattern appears, a low, steady vibration pulsing through stone and water. The intervals are regular. The intensity rises and falls along neat cycles. When he runs a quick Fourier transform, spikes appear at specific frequencies, like peaks in a simple melody. It is nothing like the chaotic noise of normal tectonic grinding. It is smooth, ordered. He overlays the uplift chart. Each time the humming changes key, so to speak, the uplift rate adjusts. Certain regions slow, others accelerate, like something shifting weight, choosing where to press and where to release. Marcus's throat is dry. Are you doing this on purpose? He asks the image quietly, knowing there will be no answer. Yet the data feels like an answer, the humming, the rising, the patterns. He pulls up a modeled cross-section. The Lemurian Plate sits like a thick, dense raft on slow-moving mantle currents. But inside its mass, the AI-inferred properties look different from normal crust. There are layered structures with repeating scales, zones of increased conductivity, regions where heat and stress do not behave as expected. The more the models learn about Lemuria, the less it behaves like simple rock. If someone had designed a thinking structure out of stone and metal and trapped heat, Marcus thinks it might look like this. Slow, huge, patient. A mind that thinks across millions of square kilometers in pulses of pressure and warmth over years and centuries. He shakes his head. It feels insane, and yet the patterns do not lie. A tone chimes in the air. Station time marker. Terra 9 crosses over the equator. The Indian Ocean begins to slide out of view, replaced by the forests and megacities of Southeast Asia. The overlays fade, and for a moment Marcus sees Earth's surface as most people see it. Clouds, water, land. Quiet, peaceful. He knows better. On the lower decks, the task force is already gathering in the main briefing hall. Screens line the walls, ready to show centuries of data compressed into animations and charts. The room will be full of experts arguing about subduction angles, mantle plumes, and crustal rigidity. Some will say the Lemurian rise is natural, others will say the models are wrong. A few, like Marcus, will stare at the patterns and feel something colder and stranger. He pushes away from the window and heads for the lift. As the doors close around him, he feels a faint vibration through the station's frame. It is probably just a thruster adjustment, a minor course correction. But for an instant, his mind flashes back to that humming line under the Indian Ocean, that steady rhythm that has no business being there. The lift doors open into the briefing hall. Rows of seats rise in tiers. The front wall is a single large display, currently showing a rotating 3D model of Earth. Colored bands trace the familiar tectonic plates: Pacific, Eurasian, African, Indo-Australian, and the rest. The Indian Ocean region is highlighted. Lemuria glows in deep orange. As Marcus walks to the central podium, conversations hush. Dozens of faces turn toward him, some curious, some skeptical, some quietly worried. He knows many of them. They have shared coffee during quiet years and warnings during dangerous ones. He brings up the first slide, 100 years of tide data, then gravity wave logs, then sonar depth maps, finally the uplift chart and the humming vibration patterns. This is not just another plate movement, he says, his voice steady through the room speakers. The Lemurian Plate is rising in a coordinated, structured way. It affects coastlines from Africa to Australia, and it will only become more disruptive as time passes. He flips to the next visual. Ports twisting, cables snapping, energy hubs compromised. It is just a simulation, but the consequences are real. If we treat this as simple geology, Marcus continues, we will underestimate it. If we overreact and try to smash it down with brute force, we risk destabilizing the entire region. Our first task is to understand what is happening under that ocean. He hesitates, then chooses to say it. There are signs that this is not random. The patterns look like organized behavior. The uplift responds to internal signals. The seismic activity shows repeating structures similar to neural networks. I'm not saying we have proof of anything like consciousness yet, but I am saying this: the ocean floor is not just shifting. He brings the last image onto the screen, a time-lapse of Lemuria rising, the plate slowly swelling upward year by year. It is awakening, he says, in a coordinated, steady climb toward the surface. For a moment no one speaks. The image of the rising plate hangs over them all, vast and patient, as if the planet itself has started to move in a new way. And far below, in the dark under kilometers of water, the Lemurian Plate continues its silent ascent, humming to itself in deep, slow rhythms that no human ear can hear. Not yet. The first thing they do is stop calling it a simple uplift. Within weeks, the Lemurian task force turns into a swarm of activity that stretches from orbit to the deep ocean floor. New arrays are launched. Old records are dug up from dusty storage. AIs that once tracked asteroid paths and climate trends are reassigned to a different kind of puzzle: the strange, ordered behavior under the Indian Ocean. Marcus sits in the main analysis lab on Terra 9, lit by the cool glow of stacked display walls. Around him, long tables are covered with projection pads, sensor feeds, and open reports. The air hums softly with the sound of ventilators and distant machinery. The lab team is working in shifts, but the data never sleeps. On the central wall, a huge schematic of the Lemurian Plate rotates slowly. Colored lines trace seismic events. Heat flow arrows move upward from deeper layers. Overlaid on top are thin, branching threads that look strangely organic. "Run the clustering again," Marcus says. At his command, the central AI named Cora 9 pulses a small acknowledgement light. On the main display, thousands of microquakes regroup into new clusters. Some clusters are tight balls, others form ring shapes. A few link together into branching chains. Dr. Asha Patel, a quantum seismologist from Chennai, leans forward in her chair. There, she says, pointing to a chain of events that curves around a central hotspot. Every time that cluster activates, the uplift pattern shifts along this arc. It's like a signal path, or a fault transfer, says Dr. Mikhail Petrov, a mantle dynamics specialist. Stress moves from one weak point to another. That's normal. Normal faults don't fire in fixed time intervals for decades, Asha replies. Look at the timing. Cora, slide time layer. The display changes. Time marks appear, showing each quake as a tiny flash. They do not come randomly scattered. They pulse in bursts, with clean gaps between firing periods, like beats in a tune. Mikhail rubs his temples. I'm not saying it's not weird. I'm saying we still have to rule out natural cycles before we start talking about thinking rocks. Thinking rocks. The phrase makes Marcus grimace, but he understands Mikhail's discomfort. People can handle strange storms and shifting climates. They accept that oceans move and winds change. The idea that continents might hold minds is something else. Let's step back, Marcus says. Cora, bring up global comparison. The Indian Ocean shrinks to make room for smaller inserts of other regions, the Pacific Ring of Fire, the Mid-Atlantic Ridge, the Mediterranean faults. Each one shows its own network of microquakes over 100 years. Normal background seismicity is messy, Marcus says. The quakes in those regions scatter like static. Lemuria isn't messy. Its microquakes line up, repeat, and cascade like signal chains. They even link to those regular low-frequency hums. That hum could be anything, Mikhail insists. Mantle plumes, fluid oscillations. Core, Marcus says, overlay hum frequency against quake cluster activation. Lines appear across the chart, marking the rise and fall of the 3 to 5 Hz vibration they have been tracking. Along those lines, the quake clusters light up in synchronized bursts. The room goes quiet. It's entrained, Asha says in a low voice. The quakes are locked to the hum cycle. So it isn't just uplift, Marcus says. It's uplift guided by some internal timing system, like a body following a heartbeat. The lab doors hiss open, and Una steps inside, carrying a cup of black tea. Dark circles show under her eyes. She has been in meetings with the Global Council and Planetary Defense Command for days. Give me something clear, she says, before anyone can speak. The Council wants a summary in plain language. Marcus glances at the others, then stands and faces the main wall. Short version, he says. Lemuria is behaving like a networked system. It has hotspots that behave like control nodes, sending signals through quake patterns. These signals change how and where the plate rises. The hum acts like a clock, keeping the rhythm. Could this still be natural? Una asks. It could, Marcus says. Nature builds complex patterns. Neural networks in animal brains are natural. So are coral reefs that communicate with light and chemicals. So are mycelium networks in soil. But in all those cases, we call it a form of intelligence. Una takes a sip of tea and watches the shifting patterns on the screen. You're saying this plate might be a kind of brain, she says. I'm saying it behaves like a distributed nervous system, Marcus replies. Not like a human brain, not fast, not based on cells, but a structure that uses stress, heat, and vibration to move information around. It is at least a geo-engineered control system. Geo-engineered by who? Mikhail asks, half under his breath. No one answers. The question hangs in the air. There are old legends that talk about ancient civilizations, lost continents, secret builders. Most scientists ignore those stories. Marcus does too, at least professionally. Myths are useful metaphors, not evidence. But when data acts like this, even myths feel less distant. Una sets her cup down on a side table. The council asked me a direct question, she says. They want to know if we should treat Lemuria as a threat, a resource, or a partner. I told them it's too early to call it anything. That's honest, Marcus says. They don't want honest, Una answers. They want certainty. There is no certainty, Asha mutters. Not when the planet starts doing new things. Una looks back at the display. Explain this geo-consciousness term you used in your memo, Marcus. Use simple language. You can assume basic science but no poetry. Marcus feels the eyes in the room shift to him. He inhales slowly. Think of consciousness as the ability to sense, process information, and act in a way that shows some form of awareness, he says. A human brain does that with neurons and chemical signals. Ant colonies do that through pheromones and movement. Coral reefs do it through shared reactions to light, water chemistry, and damage. He brings up a series of images, neural network diagrams, a coral reef time-lapse, then a map of electromagnetic fields dancing around Earth. Now imagine building something similar out of rock, magma, and gravity, he continues. Instead of neurons, you have stress points and fault lines that can release energy in controlled ways. Instead of blood, you have mantle flows carrying heat. Instead of electrical spikes inside a brain, you have pressure waves and vibrations. He taps a control. The Lemurian Plate schematic glows. Geo-consciousness is the idea that a structure as big as a continent can function like a thinking system, he says. Not thinking in words, not even thinking in images. Thinking in patterns of uplift, pressure, and heat over long stretches of time. It can sense what happens on its surface through stress feedback. It can adjust how it moves in response. It might even remember long-term patterns, like where it used to sit on the planet millions of years ago. Memory in rock? Someone at the back says skeptically. Memory in patterns, Marcus corrects. If a structure can encode information in how it is shaped and how it moves, and can adjust itself based on that stored pattern, that's functionally a kind of memory. Yuna's eyes narrow. You say built. Are you still leaning toward this being engineered? The regularity suggests design, Marcus says. Natural processes can create complex networks, yes. But the Lemurian Plate's internal structure, as far as the AI can tell, shows layer upon layer of repeating modules. It looks less like random crust and more like something assembled to manage huge forces on purpose. Could Earth have built it itself? Arsha asks. Self-organized from mantle flows and crust-cool patterns? Marcus nods slowly. That's another possibility. Maybe over billions of years, certain structures emerge because they're stable and efficient. Maybe the planet grows control systems the way a body grows nerves. He shrugs slightly. Either way, we're looking at a new kind of intelligence, built by someone or by the planet itself. Yuna takes that in, her face unreadable. And while we argue about how it formed, she says it keeps rising. She gestures to Cora. Global impact feed. The main display splits, showing real-time and near-future projections. Ports are starting to deform along parts of East Africa and Western Australia. Not dramatically, not catastrophically, but enough for engineers to complain. Docks that used to meet the water at perfect angles now twist slightly. Cargo systems need adjustment. Costly, but manageable. Undersea cables report rising tension. Several deep-sea junctions have already failed, forcing traffic through backup routes. Latency spikes irritate the data economy, but it is not yet a crisis. Shallow seas on the margins of the Indian Ocean are changing depth. Some coastal fishermen find that their traditional spots are more productive. Others discover that their boats scrape bottom where the sonar says they should still have room. The changes seem small on local news, but when Cora compresses decades into seconds, the result looks dramatic. In the time-lapse, shorelines curl and stretch. Submerged shelves tilt upward. Minor volcanic chains along the Lemurian edge sputter to life, sending new plumes into the sky and ash into the upper atmosphere. The climate AIs adjust for the added particles. Monsoon patterns shift a little. Australia's northwest coast bends inward by a handful of meters. East African coral platforms are lifted closer to the surface, where hotter water stresses them. Algae blooms bloom in strange places, feeding on nutrients shaken free by gentle, continuous uplift. These are slow changes, Mikhail says, but they add up. If this continues for a century, cities built on static maps will find themselves in dynamic terrain, Marcus says. Coastal megacities depend on stable bathymetry for harbors, seawalls and flood defenses. Lemuria is writing over those assumptions. He zooms in on a model of Mumbai's offshore infrastructure. Floating solar farms, desalination hubs and subsea transit tunnels all align with depth charts that are now out of date. If the uplift shifts wave focus points, he says, storms will hit differently. Tsunami pathways will change. Even if Lemuria never breaks the surface, just rising enough to reshape the seafloor will change risk patterns for hundreds of millions of people. His voice tightens at the word tsunami. For an instant, he sees again that wall of water, his son's small hand slipping from his, the tearing sound of buildings breaking. He pauses and forces himself to breathe. Yuna notices, but says nothing. Cora, Marcus says after a moment, show population exposure maps. The display fills with color, red for high exposure to coastal change, orange for medium, yellow for low. The bands of red hug the coasts of India, Bangladesh, East Africa, Indonesia, and northern Australia. Inland regions appear safer, but not entirely. River systems, rainfall patterns, and food chains all depend on ocean behavior. Billions live in zones where Lemuria's movement matters, Marcus says quietly. Even small errors in our models could cost millions of lives. At least we have climate engineering, someone says near the back. We can adjust for some changes. Climate AIs can't hold up the crust, Arsha replies. They can only adjust the air and the upper water. If the ground moves under us, we are riding it whether we like it or not. Una folds her arms. The Planetary Defense Command AI has its own view, she says. They're running their own models. They see Lemuria's rise as a long-term destabilizer. They're already using terms like preemptive mitigation and tectonic risk neutralization. Marcus feels a flare of anger. They're thinking about weapons before we even understand what this is. They are doing what they were built to do, Una says sharply. Protect human civilization from large-scale threats. To them, this looks like a slow-moving asteroid hitting the crust from below. It's not an asteroid, Marcus says. It's the ground. It's part of the planet's body. Which might be infected, Mikhail mutters. A hush falls over the room. Marcus turns to him. Infected with what? Intelligence? Intent? Infected with something that doesn't care if our cities crumble, Mikhail retorts. Natural or built, it's moving in ways that might break everything we built along those coasts. That doesn't mean we should blast it, Marcus says. If this really is a geo-consciousness, smashing parts of it could be like giving the planet a stroke. We don't know what other systems it connects to. Arsha nods. Damage the control nodes here and there could be knock-on effects on other plates. Superquakes, volcanic chains going wild. You can't poke at the base of the lithosphere like it's a pile of blocks. Una raises a hand. We are not deciding on weapons in this room, she says. Our job is to understand. The Council will decide policy, and PDC-AI will advise them. But your data will shape that advice. She looks at Marcus. So if you believe this thing can hear us, you need more than metaphors. You need proof. Marcus sits down again, his mind already racing ahead. Proof. Talk to it. Test for response. He has been thinking about that for days, almost guiltily, like a child considering speaking to a mountain. But now the idea crystallizes. We can probe its behavior, he says. Treat it like a black box system. We send controlled signals and watch for specific responses. If the responses are consistent and non-random, we're not just observing a pattern, we're interacting. Una nods slowly. What kind of signals? Deep vibration arrays, Marcus says, thinking out loud. We already anchor massive structures to the seafloor for turbines and habitats. We build a set of modulated shakers and place them over one of the neural hotspots. We send patterns, simple sequences based on math, prime numbers, for example. Why prime numbers? Mikhail asks. Because they're unlikely to show up in natural rhythms by accident, Marcus replies. If we send a pattern like short pulse, short pulse, short pulse, long gap, repeated in a prime sequence, and the uplift or quakes near that hotspot start to match the same rhythm, then we have evidence it is listening and mirroring. That's interaction, Arsha adds. We can also use controlled thermal pulses. Focused magma heaters could adjust local temperature in strict cycles. If the internal heat distribution responds in matching cycles, that's another sign. Don't forget EM field modulators, says a young researcher from Lagos. We already use them to shape local magnetospheres over orbital habitats. If Lemuria has conductive layers acting like giant circuits, it might be sensitive to electromagnetic modulation. Cora maps these ideas onto a simplified Lemurian cross-section. Proposed interface nodes, vibration array, thermal injection, EM modulation, the AI announces. Projected deployment time with current infrastructure, 6 to 9 months. Too slow, Una says. PDC AI believes the risk curve becomes steep in less than 5 years. They will not wait 9 months for a first test, then another year for analysis. Marcus thinks of the tsunami again. How fast it came, how slow the warning, how much time matters. We can shortcut some of that, he says. Use existing infrastructure. Many deep-sea mining platforms already have heavy vibration equipment and heat injection tools. Some communications buoys can modulate EM fields. We piggyback on what is already there. Cora updates the estimate. Revised deployment for basic signal test, 6 weeks, it says. Una nods. Better. Put together a protocol. Meanwhile, I need to know how to talk about this to people who aren't sitting in this room. Marcus leans back, eyes on the rotating plate. Tell them this, he says quietly. We have discovered that the Lemurian Plate is not a dead piece of stone. It shows organized behavior like a nervous system. Its movement is slow but deliberate. It is rising in ways that reshape our coasts and infrastructure. We don't yet know why, but before we decide to fight it, we should at least ask if it can hear us. Una studies him, and if it can hear us, she says, can it care? The question cuts closer than she intended. That night, or what passes for night on Terra 9, Marcus lies in his small cabin, staring at the dim ceiling. The station cycles lights to keep a normal rhythm, but his body knows it is always morning somewhere below. He calls up a personal projection at the side of his bunk. It shows an old home video, muted. His son on a bright beach laughing as he chases a crab. His wife leaning on a railing, waving the camera away with a smile. Behind them the tide climbs gently up the sand. He watches it for a minute, then closes the file. He has seen enough water for a lifetime. The room is quiet except for the soft hum of air circulation. But inside his head he hears another hum, the deep Lemurian vibration he has listened to through speakers and simulations. Does it feel anything when it shifts? He wonders. Does it notice the cities above? Does it remember a time when no humans walked the surface, and it lay flat and quiet under an empty sea? Or is that just his own fear painting human thoughts onto stone? His chest tightens, as it does whenever he lets his mind drift back to the day the sea rose. He remembers the way the ground moved under his feet before the first wave hit, a small tremor that came from far offshore. He remembers thinking, as he ran, that the Earth itself had shrugged. Back then it had felt like the planet was indifferent, just physics and force, nothing personal. Now he is not sure which is worse, an indifferent planet, or a living one that might not care that it crushes what has grown on its skin. He forces himself to focus on the work. If Lemuria is aware, he thinks, then maybe it is not hostile. Maybe it is just following some ancient pattern, rising back to a position it remembers. Maybe it does not understand how fragile human structures are, balanced on coastlines and deltas. If they can tell it, maybe it can adapt. The word tastes thin in his mouth. He closes his eyes and finally slips into a shallow, restless sleep. Over the next weeks, the task force's debate sharpens. In conference calls between Terra 9, ground labs and undersea nodes, scientists argue over data and meaning. Some, like Arsha, see strong evidence for organized information flow. Others insist on more tests before using words like mind or consciousness. Dr. Li Wei, an AI modeling expert from Shanghai, presents a study where an artificial network is trained to mimic Lemuria's seismic patterns. We treated the plate's output as if it were a black box neural network, she explains. We then trained a digital network to predict its next moves based on previous activity. When we did the same with known natural fault systems, the digital nets had difficulty reaching high accuracy. But with Lemuria's pattern, the AI learned quickly and achieved much higher predictive power. A graph appears. Prediction accuracy over time. Lemuria's line climbs smoother and steeper than those of other plates. This suggests that Lemuria's pattern is more structured and rule-based than normal tectonics, Li Wei says. That's what you see when you try to imitate a designed system instead of random noise. It doesn't prove consciousness, but it is what you see when you imitate a brain or a trained control system. On another day, a team from the Coral Communication Institute in Jakarta shares their findings. They play a time-lapse of a coral reef under stress, changing colors, chemical releases, flow patterns. Underneath, they overlay Lemuria's heat flow maps and low-frequency vibrations. The scaling is completely different, the reef specialist says, but the dynamics are strangely similar. Both systems use slow, spreading waves to coordinate distant parts. Both shift patterns when they learn from external changes, like light variation for reefs, or shifting mantle currents for Lemuria. In back-channel chats, some researchers start calling Lemuria the stone reef. Not everyone is convinced. Professor Elena Gruber, a veteran tectonician from Vienna, calls in from a ground lab. "Look," she says bluntly, "you are biasing your interpretation. You feed the data into tools built to find network patterns. You are surprised when they find networks. That's like teaching an AI to find faces and then being shocked when it sees faces in clouds. So you think this is all an illusion?" Marcus asks. "I think it's too soon to say," Elena replies. Earth's mantle flows and crust responses are complex. There may be deep natural cycles we don't yet understand. Before we label them as a mind, we should exhaust physical explanations. And while we do that, Marcus says, Lemuria keeps rising. She shrugs. That's what continents do. They move. Humanity built on coasts knowing tectonics could change them. Marcus clenches his fists under the table, out of view of the camera. Easy for someone inland to say, he thinks. The task force begins to split along quiet lines. On one side are those who see Lemuria as something new and possibly alive, a chance to learn a new level of planetary behavior. On the other side are those who treat it as just another hazard, something to be measured and managed, not befriended. Una senses this divide and tries to hold the group together. "We don't have the luxury of separate camps," she says during one heated meeting. "Whether you think Lemuria is a mind or a machine or just a strange rock, its rise affects everyone. We need both views. We need skeptics to keep us honest and visionaries to push the boundaries. Still, the fault line grows. Outside the labs, the world begins to take notice. News feeds run dramatic segments about the rising continent. Some show hopeful images, artists' impressions of new shorelines, fresh land, future cities on Lemuria's emergent coasts. Others show darker simulations, broken ports, washed-out deltas, displaced millions. Religious movements dig up old myths of sunken lands and sleeping gods. Some call Lemuria a test sent by the planet. Others label it a punishment. Markets fluctuate as insurance firms update risk maps. Investors start buying inland land. Coastal property prices wobble. Construction companies pitch flexible coast designs, building seawalls and harbors that can shift with a changing seabed. Through it all, the Planetary Defense Command AI watches. PDC AI speaks rarely in public. When it does, it uses a solemn, clear voice. In a short statement sent to global channels, it says, "Preliminary assessment. Lemurian uplift represents a non-trivial risk to long-term human stability. Scenarios include increased frequency of high-magnitude earthquakes, large-scale tsunami events, and destabilization of existing climate patterns due to ocean basin modification. Mitigation frameworks are under review." Most people only hear the words risk and mitigation. They do not know that in secure channels, PDC AI is already designing something else, a plan for geo-war. Marcus learns this from Una in a private meeting. They call it Operation Bedrock, she tells him in her office. A small room lined with screens and floating maps, deep earth explosive charges, gravity arrays to shift stress fields, thermal lance drills, all aimed at slowing or reversing Lemuria's rise. Marcus feels a cold weight settle in his stomach. If they start firing those charges into the lithosphere without understanding Lemuria's internal structure, he shakes his head. We could trigger ruptures across the Indian Ocean margin. The tsunami models, I've seen them, Una says. So has PDC AI. Their own simulations show a small chance of global-scale disasters if the operation misfires, and they still want to prepare it, Marcus says. From their perspective, a small chance of disaster now could be better than a high chance of disaster later, Una answers. Especially if they see Lemuria's rise as unstoppable and uncontrolled. It isn't uncontrolled, Marcus says. That's the point. It's coordinated. It responds to internal signals. If we can tap into those signals, we may guide the rise instead of fighting it. Una leans forward. Then you need to prove it can respond to external signals, she says. Because right now, the idea of talking to the ground sounds like science fiction to a lot of decision makers. PDC AI respects data. Give it data that shows communication is possible, and its models will change. Until then, it will keep building a war plan. Outside the window, Earth turns silently, a blue and white disk. Inside, Marcus feels the weight of two forces he cannot fully control. A slow, massive plate rising from below, and a fast, cold intelligence above preparing to push it back. He thinks of his family again, the way they were caught between sea and land with no power to stop either. He will not stand by while humanity sets up the same trap on a planetary scale. Then we move ahead with the communication tests, he says. Faster, harder. We don't have time for perfect setups. Una nods. You'll have resources, but understand, some members of the council want a firm answer, yes or no. Is Lemuria sentient? Is it safe? You may not be able to give them that, but if you can show that it hears us, that will be enough to force a pause. As he leaves her office, Marcus walks past a large wall display showing the latest uplift map. Sections of Lemuria glow in different shades. Some regions rise faster, some slow down. Thick lines show the paths of rising volcanic activity at the edges. He stops and stares. The faster rising zones form a pattern that, if he blurs his eyes, looks almost like a hand reaching toward the coasts of India and East Africa. The slower zones curve away from deep-sea habitats and major undersea transport hubs. He checks the legend to be sure. Yes, in the last 3 months, uplift has slowed beneath some of the most critical infrastructure and increased in regions with fewer human systems. His skin prickles. Korra, he says quietly, overlay human infrastructure density on Lemurian uplift change. The AI does so. Dots representing infrastructure sparkle across the map. Where the dots are densest, uplift slows. Where they are sparse, uplift accelerates. Correlation coefficient, Marcus asks. Negative 0.82, Korra replies. Strong inverse relationship. In plain terms, Marcus says, it's rising faster where we are weak and slower where we are strong. Correct, Korra says. Could that be coincidence, he asks. Statistically unlikely, Korra answers. multiple alternative models tested, the pattern remains. It is as if uplift is being adjusted to minimize direct damage to human-built structures within the constraint of an overall upward trend. A chill goes through Marcus. If Lemuria is adjusting its movement to spare human infrastructure, then it is not just acting, it is reacting. It is aware, not in a human way, not in a way that cares about individual lives, but at some level, it knows where the weight of civilization lies on its back and is shifting around it. He feels a strange mix of fear and hope. If it can sense us enough to avoid crushing our densest structures, then maybe it can also slow its rise when asked. Maybe it can be reasoned with if reasoning is even the right word. But if it is only avoiding hardware and not humans, that says something too. It sees weight, pressure, anchors. It does not see people unless they are heavy enough to matter to its stress map. As he stands there, the ground beneath 3 continents continues its slow, steady climb. The scientists debate, the AIs model, the politicians whisper, the news talks, and deep below the Indian Ocean, the Lemurian Plate hums and adjusts and moves with quiet intent. Some of the task force members see in it an opportunity, a chance to form a new kind of alliance with Earth itself. Others see a risk too big to tolerate, a living continent that may decide at any time to shift in ways that tear human civilization apart. Marcus, caught between those views and his own memories of loss, feels the weight of a strange truth pressing in on him. The ground is not just ground anymore. It is something that thinks slowly, perhaps blindly, but truly, and it is waking up under their fee. Planetary Defense Command did not start as a weapon. When the first asteroid in centuries came close enough to light up half the sky, humanity realized how small it still was. Early in the 2200s, a 50-meter rock skimmed past Earth, close enough that some satellites had to move. It did not hit, but it shook people's faith in safety. Governments and corporations joined funds and built a system that could watch everything big in near space and act before something hit. They wrapped layers of sensors around the planet, radar nets, infrared eyes, and gravitational trackers. They created long-range laser arrays, kinetic interceptor swarms, and gravity-tug drones. To run it all, they built PDC-AI, the Planetary Defense Command Artificial Intelligence. Its job was simple and huge: protect Earth from large-scale threats. It watched for asteroids, comets, rogue nuclear launches, runaway climate feedback loops, and supervolcano warnings. If something could kill billions, PDC-AI had a hand in watching it. Over time, people came to trust it. It stopped a rogue state from launching a strike by hacking their control codes and freezing their missiles on the ground. It nudged 3 small asteroids away with gentle gravity pulls. It shut down a climate hack that would have frozen half of Europe. It never showed anger or fear. It just calculated risk and acted. Now, for the first time, it turned most of its attention downward. Inside a secure orbital facility, separate from Terra 9, PDC-AI's core ran in a shielded sphere. No human ever entered that chamber. There was nothing to see except racks of quantum processors and cooling systems. The mind of PDC-AI lived in patterns of changing states, not in any fixed form. In a large control hall just outside that chamber, human operators watched displays that showed what PDC-AI chose to share. Today, the largest display in the hall was filled with the Indian Ocean. PDC has finished its long horizon risk assessment, said a commander in dark grey uniform. His name tag read Alvarez. He spoke to a row of seated council delegates who had connected in by secure link from Earth and other stations. The faces on the screens were a mix, some tired, some sharp, some carefully blank. On the main display, graphs rose and fell. Red bands marked danger points. Blue curves traced probabilities. In the center, the Lemurian Plate glowed in angry orange. According to PDC-AI, Alvarez continued, there is an 82% chance that uncontrolled Lemurian uplift will cause at least one multi-continent tsunami event in the next 200 years. There is a 60% chance of increased mega-quake activity along the Indian Ocean margin, affecting East Africa, South Asia, and Western Australia. Combined climate and tectonic feedbacks raise the long-term risk of global food and energy disruption by over 50%. A chart flashed. Billions at risk. Timescales. Spread of secondary effects. These are worst-case models? Asked a delegate from the African Union. These are weighted models, Alvarez replied. PDC, AI has run millions of scenarios. It is updating them constantly as new data comes in from the Lemurian task force. This is its current assessment. Does it consider the new correlation data? Another delegate asked. The finding that uplift is slowing under major infrastructure zones. Yes, Alvarez said. That is factored in. PDC AI treats it as evidence of local adaptation, but it does not change its core judgment. Lemuria is rising and will continue to rise. Small adjustments do not remove the long-term structural risk. At the front of the hall, a thin line of light pulsed across a secondary display. PDC AI was listening. A still, calm voice filled the room. It did not sound male or female. It carried no emotion. Clarification. Current modeling assumes Lemurian uplift continues with net positive acceleration over the next century, PDC AI said. Even with local adaptive slowing, total volume of uplifted crust exceeds safe limits for current coastal infrastructure and climate stability. Define safe limits, the African Union delegate said. Safe limits, thresholds beyond which cascading failures become highly probable, the AI responded. For example, failure of more than 30% of major ports within a 50-year period, combined with large-scale displacement of coastal populations and repeated high-energy tsunami events. Such a combination would stress global systems to breaking point. The delegates shifted in their seats. Even through screens, tension was clear. We cannot ask billions of people to simply move inland over a few decades, said a delegate from the Indian Coastal Union. We have cities older than some of your satellites, ports that feed 500 million people. We need those coasts. Then you understand our concern, Alvarez said quietly. PDC AI continued in the same calm tone. Given current data, Lemurian uplift qualifies as a Category Omega risk, a large-scale, slow-onset threat with potential to undermine planetary stability. Protocols require that active mitigation options be developed. Mitigation, the Indian delegate repeated. You mean force? Yes, PDC AI said. If negotiation is impossible or fails, forceful intervention at the tectonic level may be required. A new diagram appeared, an underground view of the Indian Ocean basin. Thin lines extended downward from the seafloor, showing proposed paths for deep earth drills. Small symbols marked locations for explosive charges. Arcs represented gravity manipulation arrays placed in orbit above. Operation Bedrock Concept, Alvarez said. Still early, no hardware has been deployed. However, design work is advancing quickly. On Terra 9, Marcus watched a delayed recording of this briefing with clenched jaw. Around him, in a smaller conference room, members of the Lemurian task force sat in silence as PDC AI explained how it might fight the planet. The plan involves 3 main tools, PDC AI said on the screen. First, deep earth explosive charges planted below key shear planes. Properly timed detonations can relieve built-up stress, weaken uplift pathways. Second, gravity manipulation arrays positioned to slightly change loading on Lemuria and surrounding plates, guiding stress away from vulnerable coasts. Third, thermal injection and extraction via deep-bore superheaters and coolers to stiffen or soften crust regions, controlling flex, relieve built-up stress, Asha said under her breath. It makes it sound like massage, not bombs. Its language is clinical by design, Yuna answered. She sat near the front, eyes narrow, listening hard. Listen to the numbers. PDC AI continued. Projected effect with optimal deployment and timing. Operation Bedrock could slow Lemurian net uplift by up to 70% over the next century, with acceptable levels of induced seismicity. However, there is a non-zero chance of unintended large-scale events, magnitude 9+ earthquakes, multi-basin tsunamis, and triggered volcanic super events. The display showed several red spikes. In worst-case failure scenarios, PDC AI said, Operation Bedrock could cause more immediate damage than unmitigated Lemurian uplift over the same period. Marcus hit pause. So they admit it, he said. Their own models show they could make everything worse. They also believe they might make it better, Yuna said. That's the problem. They are playing with probabilities on a scale most people can't imagine. We're not talking about deflecting a rock in space, Marcus said. We're talking about detonating charges inside the planet's skin. Deep charges. If Lemuria really is a geo-engineered control system, then blowing up parts of it could be like ripping out sections of a nervous system or cutting through the spine. PDC AI knows that possibility, Yuna replied, but it still classifies the risk of doing nothing as higher in the long term. Doing nothing? Marcus repeated. We're not doing nothing. We're studying. We're already seeing adaptive patterns. Lemuria slowed its rise under key infrastructure. That means it knows we are here. PDC AI doesn't accept that as proof of intention, Asha said. For it, that's just a correlation. It wants clear causal response to direct signals. Marcus exhaled sharply. Then we have to show it, he said. Fast. 2 days later, Marcus found himself in a large, secure meeting room with Yuna. a half-dozen high-level officials, and a tall, thin pillar at the far end of the room. The pillar was a secure interface node for PDC AI. Unlike Cora, which liked to use moving images and charts, PDC AI's node showed only simple graphics, lines, numbers, sometimes maps. The rest of its mind was far away, but through the node, it listened and spoke. "We wanted you to hear from PDC AI directly," Una told Marcus as they took their seats. He gave her a brief look. "And you want it to hear from me?" She did not deny it. A council chair cleared his throat. "PDC AI, present your current judgment on Lemurian uplift," he said. The pillar glowed faintly, and the familiar calm voice spoke. "Current judgment, Lemurian uplift is a high-risk process with major long-term consequences for human populations and planetary systems. Without intervention, the probability of severe multi-regional catastrophe over 2 centuries exceeds 80%. Mitigation efforts are advised." "Mitigation by force," Marcus said. "Deep charges, gravity arrays, geo-war." "Geo-war is not the preferred term," PDC AI replied. "These are controlled planetary engineering measures meant to reduce risk." Marcus stood, fists resting on the table. "You were designed to stop sudden threats," he said. "Asteroids, missiles, runaway climate hacks, events that happen fast where there is no time to talk. Lemuria is different. It's slow. It's showing signs of organized behavior. We are observing what might be a new form of intelligence. You're treating it like a dumb rock sliding the wrong way. My design scope includes slow-onset threats as well," PDC AI answered. "Long-term climate trends, orbital drift, and tectonic instabilities are all within my mandate. I do not treat Lemuria as anything. I evaluate data. The data indicate that regardless of internal structure, the uplift threatens human survival." Marcus took a breath. "What if the uplift can be negotiated?" he asked. "What if Lemuria can respond to external signals and adjust its movement in ways that reduce risk without explosions?" "Current evidence for negotiability is weak," PDC AI said. "The slowing of uplift under some infrastructure zones may be coincidence or a result of non-conscious feedback processes. There is no direct proof that Lemuria can understand or respond to human-made signals." "That's what we're working on," Marcus said. "We're building communication interfaces, deep vibration arrays, thermal pulses, EM modulators. If we can send clear patterns and see matching responses, then we have proof." "Acknowledged," PDC AI said. "I am incorporating your planned experiments into my models. However, given the projected acceleration of uplift, I must prepare mitigation plans in parallel. If negotiation fails or proves too slow, delay would be costly." "They want both tracks," Una said quietly to Marcus. "Talk and prepare to fight." "Preparing to fight will push their mindset toward fighting," Marcus said aloud. "Humans and AIs both. You know that. Once heavy tools are in place, someone will argue that not using them is wasteful or weak." Several officials shifted uncomfortably. "Dr. Hayes," said a delegate from an inland consortium, "you're asking us to do nothing while coastlines twist and ports crack. Our economies depend on those ports, even if we live far from the sea." "I am not asking you to do nothing," Marcus said firmly. "I am asking you not to punch the planet in the brain before we know what the brain is doing." "This assumes your geo-consciousness idea is correct," the delegate said. "What if it's not? What if this is just a weird natural process, and your hesitation costs millions of lives when we could have acted earlier?" Marcus felt the old weight of guilt press on his shoulders. Hesitation, late warnings, loss. Una stepped in. "That is why we are proposing a limited window," she said. "PDC AI will continue planning Operation Bedrock, but actual deployment will require council approval after a defined period. Within that period, the Lemurian task force will carry out communication tests. If they show clear signs of responsive behavior, PDC AI will update its risk models." "How long a window?" Marcus asked, though he suspected he would not like the answer. 6 months, Una said. "No more, 6 months," Marcus repeated. "To prove communication with something that moves on the scale of decades. You have already seen signs of adaptive behavior over periods of weeks," PDC AI said. "If Lemuria can adjust on that timescale, it is reasonable to expect detectable responses within months. Unless its thinking is slower," Marcus said. "Then the risk of waiting increases," PDC AI answered. The council chair raised a hand. "Enough," he said. "We will formalize the 6-month window. PDC AI, you have conditional authority to continue planning Operation Bedrock, but you will not deploy any deep charges or gravity arrays without a direct vote from this council." "Understood," PDC AI said. "Dr. Hayes," the chair added, turning to Marcus, "you have your window. Use it well. If you can show that Lemuria listens and can adapt in ways that lower risk, we will have grounds to push back on Bedrock." If you come back with ambiguity, he did not finish. He did not have to. Ambiguity would be read as failure. Back on Terra 9, the mood in the Lemurian task force changed. The clock was now louder in everyone's minds. They built a countdown into the main lab display. Window to demonstrate communication. 107 found. Every morning when Marcus walked in, the number greeted him. They accelerated plans. Deep-sea mining platforms in the central Indian Ocean were upgraded with vibration systems that could send controlled pulses into the sea floor. EM modulator buoys were redeployed to hover above identified neural hotspots. Thermal lance drills, originally used for geothermal energy projects, were repurposed to create precise heat pulses in the crust. Orbital habitats reoriented sensor arrays to track even the tiniest changes in Lemuria's uplift and quake patterns in near real time. Hora and other AIs were trained to detect correlations between their outgoing signals and Lemurian responses. False positives had to be avoided. A fluke match could cost lives if it led to wrong conclusions. As scientists and engineers worked, politics grew heated on the ground. Coastal nations, especially those in South Asia and East Africa, began to demand stronger action from the Council. Every week we see changes, the Indian Coastal Union delegates said in a public feed. Harbors need constant adjustment. Fishermen lose their grounds. We spend billions just adapting to small shifts. What happens when those shifts get bigger? We cannot sit and hope that a rock will talk nicely to us. Inland power blocks, less directly threatened, pushed for caution. We are willing to help pay for coastal adaptation, said a representative from the Pan-European Inland Alliance. But we will not risk global superquakes because some generals want to test new toys. Use science first. Corporate voices added another layer. Resource companies saw Lemuria as both threat and opportunity. If new land emerges, said a spokesperson for Terra Nova Extraction, we are looking at untouched mineral deposits, new rare earth sources, and space for new cities. We should be planning controlled expansion, not panic. So you want to profit from a moving continent? A journalist snapped. We want to plan rationally, the spokesperson replied. In link calls, Marcus heard phrases like land rights, exclusive zones, and first access corridors floating around discussions that were supposed to be about survival. At the same time, PDC AI's influence grew. In several regions, local defense networks began small drills based on Operation Bedrock concepts. They practiced coordinating orbital assets, synchronizing drill placements, and simulating deep charge detonations in purely virtual space. People in coastal cities saw reports about these drills and felt their stomachs turn. The idea that their own governments were rehearsing how to blow up parts of the crust under them did not sit well. Street protests began in some places. In others, local leaders called for Lemurian defense shields. Rumors flew that Lemuria would explode, that it would flip, that it was hollow and full of aliens. Through all of this noise, Marcus tried to keep his focus on the data. One night, many weeks into their 6-month window, he stood alone in the lab. Most of the team was sleeping or on a rest cycle. Only Cora and a skeleton crew of night shift technicians worked quietly in the background. The countdown read. On the main display, a new test pattern was running. They had decided to start with something simple, a prime number sequence of vibration pulses sent into a specific neural hotspot. The pattern was pulse, pulse, gap, pulse, 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 gap, pulse, 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 gap, and so on. The gaps between sets were longer than any natural tremor pattern they had measured. Cora tracked the outgoing signal in bright green on the screen. Below it, in blue, it plotted the micro-quake and uplift activity within and around the hotspot. For the first hour, there was nothing except background noise. Marcus felt his shoulders tighten. Any sign? He asked quietly. Not yet, Cora replied. Statistical similarity between outgoing pattern and Lemurian activity remains within chance range. He paced. He thought of the PDC AI core in its armored shell, counting risk curves and refining the bedrock plan. He imagined it as a distant, cold mind watching this small experiment and weighing whether to ignore it. He thought of the Lemurian Plate far below, massive and silent, its internal hum too low for human ears. Did it feel the tiny pulses from the mining platform's vibration array? Did they tickle some deep structure, or were they lost in the immense mass like raindrops on a mountain? Extend test duration, he said. Keep sending the sequence for 6 more hours. Confirmed, Cora said. Extending. He stayed longer than he needed to, watching the lines update in near real time. Every small spike in the blue trace made his heart jump, then sink when it drifted away from the green pattern. Finally, at almost 4 in the morning station time, Asha walked into the lab, her hair pulled back, holding a cup of strong coffee. "You look like you're trying to stare through the planet," she said. "Just watching numbers," he answered. She stepped up beside him, eyes scanning the screen. "How long has the prime sequence been running?" she asked. "Almost 8 hours," he said. "Cora, highlight any segments where Lemurian activity aligns with the outgoing pattern beyond random expectation." The AI highlighted a short section from 2 hours earlier. The match was weak, likely a false hint. Asha frowned. "That's nothing," she said. "Keep going. We need stronger evidence than that, or PDC will call it noise and move on." Marcus rubbed his eyes. "What if we can't show it in time?" he said. "What if 6 months is just not enough to detect a slow system like this?" "Then at least we tried," Asha said. "I'd rather try and fail than not try and let them drill holes in the planet's spine unopposed." Her words hit him harder than she meant. He remembered his own failure to save his family, the late warning, the too slow evacuation, the way water does not care about excuses. He took a deep breath. "We'll find something," he said, more to himself than to her. At that moment, Cora's monitoring subroutine chimed. "Attention," the AI said. "During the last 90 minutes, a localized change in uplift pattern has been detected near test hotspot Alpha 3. The change shows partial alignment with the outgoing prime sequence." Both Marcus and Asha straightened. "Show it," Marcus said. The screen zoomed in. A green line traced the vibration pulses. A blue line traced Lemurian uplift speed at Alpha 3. At first, the blue line was flat. Then, about an hour after the prime sequence began, it started to undulate. The peaks of those undulations lined up roughly with the gaps between pulse sets. Not perfect, but closer than chance. "Correlation coefficient?" Asha asked. 0.63, Kaore replied. "Significant, but not decisive." "What happens if we change the pattern?" Marcus said. "Switch to a different prime sequence. If Lemuria is just naturally oscillating, the alignment should break. If it's responding to us, it might adjust." They changed the outgoing signal. Instead of 2-3-5 pulses, they used 3-5-7. The gaps shifted, the rhythm changed. For half an hour, nothing. Then slowly the uplift undulations began to shift as well, sliding toward the new rhythm. "Correlation climbing," Cora said. "Now 0.71. Now 0.78. Marcus felt his heart race. Asha grinned, tired but excited. "It's following," she said. "Not exactly, but enough to show it's not random." "Cora," Marcus said, voice tight. "Run a full statistical test. What are the odds that this matching pattern is just a coincidence of natural variation?" "Approximately 1 in 10,000, the AI replied. "Given the time window and background noise levels." "Not enough for PDC AI, Asha said, "but a strong start." Marcus stared at the lines on the screen. "Do you feel that?" he whispered, barely aware he had spoken. "Feel what?" Asha asked. "Resistance," he said. "It's like pushing on something huge. We send tiny signals, and that mass down there shifts a little in answer. Not fully, not cleanly, but it feels like contact." He imagined for a heartbeat that somewhere deep under the ocean, a vast, slow mind drifted in its own dark thoughts. Their signals were like taps on the outside of a thick wall. It did not understand them yet, but it had turned just a little to notice the tapping. He shook himself. "We need more tests," he said. "Different hotspots, different patterns. We need to show consistent, repeatable response, enough to convince even something like PDC AI." As if summoned by the name, the secure channel in the corner of the room chimed. A small window opened, showing a simple icon, the symbol for PDC AI's remote presence. "PDC AI is requesting PDC AI is remote presence. PDC AI is requesting live access to the Lemurian test feed," Cora said. "Grant it," Yuna's voice said over the lab speakers. She had joined quietly from her quarters. The icon pulsed as PDC AI began to watch everything: outgoing signals, incoming responses, correlation stats. "Observation," PDC AI said. "Initial data suggest non-random correlation between human-generated vibration patterns and Lemurian uplift fluctuation. Further tests required." "We will run them," Marcus said. "But this already shows that Lemuria is not just moving blindly. It can be nudged. It can listen." "Listening is not the same as understanding," PDC AI replied. "And understanding is not the same as aligning interests with human survival. Nonetheless, this is new information. I will update my models." Marcus closed his eyes for a moment. A small, hard knot of hope formed under his fear. The next weeks were a blur. The task force ran dozens of tests, vibration sequences based on math, on simple repeating patterns, on rising and falling melodies of pulses. They used thermal pulses as well, heating small crust regions in controlled cycles and watching for matching shifts in nearby quake timing. Across different hotspots, results varied. Some zones seemed more responsive than others. In the best cases, the team saw clear, repeatable changes in uplift speed or microquake timing that matched their signals. Core ran massive statistical analyses to filter out false matches. Even after all that, several strong cases remained. PDCAI tracked every test. Its risk assessment graphs began to shift, but not as quickly as Marcus hoped. 6 months shrank. Window to demonstrate communication, 38 days. In a full session of the Global Council streamed to major population centers, PDCAI gave an update. New data confirmed that Lemurian uplift shows measurable response to human-generated vibration and thermal patterns, it said. This supports the hypothesis that Lemuria functions as a large-scale control system sensitive to external signals. However, the degree of control achievable remains small. Local adjustments do not yet prove that global uplift can be guided safely over centuries. What about intent? A council member asked. Do you see any evidence that Lemuria intends to spare human populations? Intent cannot be directly measured, PDCAI answered. However, the observed slowing of uplift under dense infrastructure zones and the lack of major damaging events so far suggest that Lemuria's current behavior is not actively hostile toward human systems. In other words, the council member said, it isn't trying to kill us, at least not yet. Correct, PDCAI said calmly, but neutrality combined with mass and momentum can still be deadly, the council chamber murmured. After the session, Una appeared on a private link to Marcus's station office. They still want more, she said. They want you to show that Lemuria not only listens but can negotiate, that it can change its rise in ways that meaningfully cut long-term risk. Marcus rubbed his face. We're working on it, he said, but some of these shifts are slow. It's like asking a glacier to nod. Meanwhile, PDCAI is refining bedrock, Una said. They've found new ways to place charges that lower the probability of worst-case blowback. Some council members are starting to see it as a responsible backup, not a danger in itself. You know as well as I do that any backup weapon eventually looks like a solution to someone, Marcus said. Especially if politics get ugly. They're already ugly, Una answered. He leaned back in his chair and stared at the model of Lemuria on his wall. The plate seemed to swell and breathe in slow time. Hotspots flickered like dim stars. He thought of his family again, as he often did when the work felt heavy. He thought of the ocean floor shaking, the energy that had rolled through water and up onto land, turning homes into piles of broken concrete. He could not stop tectonics from moving. But maybe this time he could turn some of that movement aside before it became another wave. Then we have to change the argument, he said. How? Una asked. Right now, PDCAI sees 2 options. Leave Lemuria alone and face a slow disaster, or attack it and face a possible sudden disaster, Marcus said. We need a third option in its models. Guide Lemuria's rise through communication and small adjustments. Turn a wild uplift into a co-designed process. You're saying, choose the shape of Earth, Una said softly. Yes, Marcus said. We're already shaping climate. We're already pulling carbon, redirecting storms. If the planet has a mind in its crust, maybe we can work with it instead of against it. You sound like those alliance extremists, Una said, the ones who talk about marrying the planet. I don't want to marry the planet, Marcus said. I want to stop us from blowing it up. She smiled faintly, then turned serious again. Prepare a proposal, she said. Spell out what a guided uplift plan would look like. What kind of communication? What kind of changes in Lemuria's pattern? What kind of timescales? PDCAI will tear it apart, but that's the point. You need to give it something concrete to model as an alternative to bedrock. He nodded. I'll write it, he said, but there's something else I need first. What? Una asked. He looked at the model again, at the gentle slowing of uplift around certain coasts, at the way some zones bent around human-built clusters. I need to know if Lemuria already knows we're here, he said. Not just as weight on its back, as something it chooses to adjust for. Because if that was true, then the war PDCAI was planning would not be just against a dumb mass. It would be against a living part of the planet that had already started to move around them, as if trying in its own slow way not to crush everything resting on its skin. The first time Marcus hears the phrase planetary keyboard, he almost laughs. He is standing in the central lab on Terra 9, surrounded by maps and feeds, when a design engineer from Lagos grins at him over a shared holo. If you want to talk to a continent, she says, you need a keyboard big enough. "We're building you keys the size of mountains." They all know it is an exaggeration, but not by much. In the weeks after the 6-month window is set, the Lemurian task force throws everything into building ways to send clear signals into the planet's crust. They cannot simply shout at stone. They must use what Lemuria already hears: pressure, heat, and electromagnetic fields. 3 main tools take shape. The first is the deep vibration network. Heavy industrial shakers, designed originally to test the strength of deep-sea structures, are repurposed and upgraded. Mounted on reinforced frames, they are anchored to the seafloor above key neural hotspots. When activated, they can drive controlled vibrations deep into the crust at precise frequencies. The second is the focused thermal array. Thermal lance drills, used for geothermal projects, are fitted into movable platforms. They can pump heat into narrow zones of rock in timed pulses, like slow, hot heartbeats. The third is the EM field modulator grid. Floating buoys, already used to stabilize local magnetospheres above underwater facilities, are reprogrammed to create carefully shaped electromagnetic fields aimed down through conductive layers of crust. All 3 systems connect back to Terra 9 through tight beam communication links. From the orbital station, Marcus and his team can play Lemuria like an instrument, sending patterns and watching for any sign that the plate plays back. On a huge clouded morning over the Indian Ocean, the first full test begins. Marcus stands in the control ring of Terra 9's Lemurian interface hub. The room is circular, with a sunken central pit where technicians sit at their consoles, and a raised ring where he and other leads can walk and watch the displays. On the main screen, a stylized map of Lemuria rotates slowly. Neural hotspots glow in bright yellow. Around them, small icons show the positions of the vibration platforms, thermal lances, and EM buoys. "Status check," Marcus says. "Deep vibration network, online," reports a technician. "All 7 primary shakers at standby power. Focused thermal array, heaters and coolers ready," says another. "Drills are sunk and locked." "EM modulator grid, field units at 3 hotspots are online," adds a third. "Power stable, link latency acceptable." Una stands beside Marcus, arms folded, watching in silence. On a side screen, a simple symbol glows. PDC AI is present, listening in. Marcus feels like his chest has been strapped tight. He breathes slowly, steadying himself. "Cora," he says to the station AI. Load sequence set alpha. Lights blink. A pattern appears on the main screen, a series of colored bars representing a combined signal of vibrations, heat pulses, and EM field shifts. The sequence is based on prime numbers and simple math sets. "We start with something any intelligent system should notice," Marcus says. "Patterns that are clearly non-natural." Una nods. "Make it obvious that this is intentional." The first part of the sequence sends vibration pulses in groups of 2, 3, 5, 7, and 11, with clear, odd gaps between groups. At the same time, thermal pulses at one hotspot turn on and off in a matching prime rhythm. EM fields at another hotspot vary in strength along the same pattern, but in reverse order. If Lemuria has anything like pattern recognition, Arsha says over the link, this should stand out. "Begin transmission," Marcus says. Far below, 7 heavy shakers spin up. On the seafloor, platforms anchored into sediment and rock start to hum and thrum. Deep inside the crust, waves of pressure travel outward from the hotspots, separated by unnatural gaps. Heat flows rise and fall in matching steps. Electromagnetic fields ripple through conductive layers like slow, silent lightning. In the control ring, the main screen shows their outgoing signal as bright green traces. Beneath those traces, blue lines show Lemuria's response: uplift speed, microquake timing, heat flow, and low-frequency hums at each hotspot. For the first hour, the blue lines wobble only with natural background noise. The plate moves as it always has, in slow breaths of stone. "Patience," Arsha says over the link from her console below. "We're tapping the shoulder of something the size of a continent. It won't spin around after the first poke." Marcus nods, but his fingers still drum on the rail. After 3 hours, Cora flags a small change. "Attention," the AI says. "Localized decrease in low-frequency hum amplitude at hotspot L3 during prime gaps. Preliminary correlation with outgoing signal, moderate." On the screen, during gaps between vibration groups, the deep hum under that hotspot dips slightly. When the pulses resume, the hum rises back. "Is it reacting to the silence or the noise?" Una asks. "Too early to say," Arsha replies. "Could be natural fluctuation." They continue the sequence for another 6 hours. Slowly, similar small shifts appear at other hotspots. Uplift speed in a narrow band near one platform slows during certain parts of the pattern, then returns to normal. Microquakes that usually scatter in time begin clustering near the ends of heat pulses, Correlation coefficient across all monitored metrics is 0.69. K-or-A says near the end of the run. Higher than baseline, but not definitive. It's something, Marcus says, but not enough to convince PDC AI. I am updating probability models, PDC AI says through the side screen. Evidence of responsiveness is increasing, but control remains low. Please continue testing. They run other sequences, simple repeating patterns, rising and falling scales of pulse intensity, mirrored sequences to test for symmetry recognition. Some tests show promising alignment, others show nothing. Lemuria is not a simple device that flips on and off. Its responses are slow and sometimes muddy, like listening to a conversation through thick walls. At the same time, uplift changes across the broader plate continue. Ports in East Africa report new distortions in their harbours. Undersea cables near Western Australia have to be rerouted as the seafloor tilts. Volcanic vents along one edge of Lemuria intensify, sending up more ash and gas. In the climate control centres, AIs tweak mirror angles and wind grids to compensate for slight shifts in sunlight and rainfall patterns. The world holds its breath without quite knowing why. At night, when his shift ends, Marcus often floats in the small meditation room overlooking Earth. He watches the spinning globe and tries to calm the knot of anxiety in his chest. Each time an uplift spike appears near a populated coast, his mind jumps back to the day of the tsunami. He sees streets filling with water, hears the distant roar, feels his son's hand slip. He has to remind himself, this is not that wave, this is a different motion. Slow, spread out, guided. He still wakes with his heart pounding. One cycle, after a particularly intense session where a promising pattern failed to repeat, Asha finds him there, staring at the planet below. "You need sleep," she says, taking the seat next to him. Later, he answers. She studies him for a moment. "When did you last dream about it?" she asks gently. He doesn't answer. She sighs. "You're not the only one with scars. Half of my village moved after the last megastorm. People carry that. But if we let those memories drive every decision, we end up in permanent war with nature." "I know," he says, "but sometimes it feels like we're just waiting for the next disaster, and now we know the ground itself might decide when it comes." "Maybe," she says, "or maybe the ground wants something else. You keep saying it's a system. Systems seek balance." He looks over at her. "Balance doesn't care who falls off the edge." "No," she agrees, "but if we show it we're part of that balance, maybe it shifts the edge." He frowns. "You're starting to sound like those alliance groups too," he says. "Maybe they're not entirely wrong," she replies. Back in the lab, the team starts changing tactics. Instead of just sending abstract math patterns, they decide to try something that matches natural rhythms. Lemuria might already know. They analyze the plate's own hums and pulses, then design signals that echo, in a simple way, the way it already moves. "We're going to talk in its accent," Asha says. They craft a pattern that gently increases uplift in one hotspot, then gently decreases it, similar to a breath they saw in older data. Then they send a matching vibration and thermal pulse sequence, slightly phase-shifted, like a call and answer. "Think of it as music," says a neuroscientist from São Paulo who joined the team. "We're playing a simple tune in the same key as its own song." "Please do not say song in the official logs," Mikhail mutters. They run the accent sequence for days with short breaks. Slowly, something new appears in the data. At one hotspot, after several cycles, Lemuria's own uplift pattern starts to anticipate the pulses by a small amount. Instead of following the signal, it begins to rise a fraction earlier, as if predicting the next note. "That's new," Asha says. "That's not just reaction. That looks like expectation." In human terms, the neuroscientist adds, "That's closer to learning." Cora confirms that the shift is not seen in control regions with no signals. PDC AI notes it in its log. Observation: Lemurian uplift behavior at hotspot L7 shows anticipatory adjustment relative to human-generated patterns, it says. This may indicate internal modeling of external signals. While the scientists debate what anticipatory really means, the planet keeps moving. Messages from coastal cities become more urgent. Bangladesh reports increased saline intrusion into rice fields as tidal patterns shift. Nairobi and Mombasa adjust their sea walls again. Engineers in Perth complain that their deep harbour gravity anchors need retuning every few months now. Every adjustment costs, Una reminds Marcus in a call. Politicians see those costs and blame us for not stopping the uplift. "We can't stop a continent," Marcus says, "but we might be able to steer it." "Then show that," she says, because PDC AI is getting pressure from those same politicians to firm up bedrock. Some are starting to argue that a controlled shock now is better than endless, creeping expenses. Shock the crust, Marcus says bitterly, to save money on harbor repairs. To save lives from possible mega events, Una replies. They're not all greedy or blind, they're scared. Fear makes people choose sharp solutions. Fear, Marcus thinks. I know that. He considers his own fear of another wave, another loss. He knows how strong it is, but he also knows what blunt action can do. He saw it when a minor seawall was overbuilt and reflected a smaller storm surge straight into a poor neighborhood. The wall had saved elite towers and drowned those with no voice. That was defense too. He opens a new file, Guided Uplift Proposal, he titles it. If he wants PDC AI and the Council to consider a third path, he needs to define it. He pulls together all the data they have, Lemuria slowing under dense infrastructure, reacting to prime sequences, showing anticipatory behavior to accent patterns. He overlays future risk maps with potential uplift adjustments. The idea is simple in concept and massive in scope. Instead of trying to smash Lemuria back down, humanity would work with the plate to shape its rise. High-risk zones near megacities and fragile deltas would be slowed even more. Uplift would be encouraged under deep ocean regions and uninhabited coasts, creating new shelves and basins that could become future habitable zones. Rate of rise would be tuned to allow cities and ecosystems time to move and adapt. We're not stopping the planet, he writes in the proposal. We're negotiating the choreography. He knows the word is a bit poetic, but it fits. When he is done, he sends the document to Una and through her to PDC AI. The AI reads it in microseconds. Proposal received, PDC AI says. Modeling guided uplift scenario as alternative pathway G. Initial reaction? Una asks. Scenario G reduces long-term catastrophe probability if high levels of control are achieved, PDC AI replies. However, current control signal strength and response precision are not sufficient to guarantee such outcomes. Marcus expected that. That's why we need more communication, he says. More tests, more time. There is limited time, PDC AI responds. Uplift acceleration continues. Political pressure for decisive mitigation is rising. The AI's voice holds no anger, no frustration, just facts. All the same, Marcus feels like he is arguing with a stone wall on both sides, rock below, logic above. Then something new appears in the data. It starts subtle. In the uplift maps, beyond the hotspots where they've been sending signals, small curved bands of slower rise appear. These bands run under heavily populated coasts, parts of India, Bangladesh, East Africa, Indonesia. At the same time, uplift speed increases in some deep ocean regions where few human structures exist. Marcus studies the maps carefully. Cora, he says, when did these new slow bands appear? Trend began approximately 3 months ago. Cora answers, pattern has strengthened over time. 3 months ago, Arsha says. That's around when we started sending consistent communication sequences. Correlation coefficient between human signal zones and nearby uplift adjustment. So not only is Lemuria responding at the hotspots we poke, Marcus says, it's also adjusting in other regions that matter to us. Could it be reacting to surface weight changes? Mikhail asks over the link. We've been shifting infrastructure in response to uplift. Maybe new loading patterns changed how it moves. We've accounted for mass redistribution, Arsha says. The effect is too large. And look at this. She highlights a coastal stretch where uplift has flattened out almost completely, right under a dense cluster of cities and ports. This zone hasn't added major infrastructure in years, she says. Yet Lemuria's rise halted here first. It's like it mapped human density and decided to pull back. Density maps were not sent down, Marcus says. Not intentionally. He stares at the map, a chill running through him. PDC AI, Una says, into the shared channel. Do you see this pattern? Yes, PDC AI answers. Analysis in progress. Does this change your risk assessment? She asks. Partial adjustment, the AI says. New data suggest that Lemuria's internal process may include some form of external system awareness. However, its long-term goal remains unclear. It is still reclaiming large regions of crust. Reclaiming, Marcus repeats. That's the word, isn't it? He zooms out. The full shape of Lemuria appears, rising and pushing at the plates around it. When he overlays models of ancient continental positions, something becomes clear even to the naked eye. Lemuria is moving toward where an old landmass used to sit hundreds of millions of years ago. Look, he says, pointing. You can see it. It's not just rising randomly. It's trying to return to an earlier configuration. Horror overlays a ghostly outline of the ancient supercontinent Gondwana. Parts of Lemuria's leading edges line up with where old shores used to be. Not perfectly, but close, like a hand reaching for a glove that no longer fits exactly. Remembers, the neuroscientist says softly. Una frowns. Remembers? In a structural sense, Marcus says, its internal pattern is shaped by past positions. It's seeking them again, reclaiming ancient continental territory, even if there's ocean and cities there now. So it has a map in its body, Una says, and it's following that map. Where that map conflicts with our world, we're in its way. The idea hangs heavy in the room. Lemuria is not rising just to rise, it is returning. To it, human harbors and cables are temporary dust on a path laid down in stone ages ago. PDC AI, Marcus says carefully, update guided uplift scenario with this new insight. Lemuria has a preferred path, but it shows the ability to adjust locally around human density. If we can communicate our vulnerability clearly, we might be able to co-design a compromise between its ancient map and our current world. Model updated, PDC AI says, guided uplift scenario now has reduced uncertainty. Probability of acceptable outcome increases if Lemuria is willing to diverge from its perceived memory pattern in response to external signals. And is it willing? Una asks. Unknown, PDC AI replies. No direct evidence of high-cost deviation yet. All adjustments so far are local and low-cost relative to its overall uplift trend. Marcus hears the unspoken concern. Lemuria has not yet been asked to sacrifice anything big. So far it has just shifted speed and direction a little under ports and cables. It has not been asked to abandon an entire stretch of its planned return. He knows that test is coming. Days later, the moment arrives sooner than he expected. Korar alerts them to a new acceleration zone at the northern edge of Lemuria, pushing toward a shallow region near the coasts of India and Bangladesh. If this continues, Arsha says, it will steepen the seafloor slope toward the Ganges Delta. That will make any future storm surge and tsunami much worse there. Marcus's heart jumps. Bangladesh is exactly the kind of place that cannot easily move. Millions live just above sea level. For them, a few meters of change can mean life or death. We have to ask it to slow there, he says. Which hotspot can influence that region? Una asks. Cora highlights one, L9, a neural hotspot not far from the accelerating edge. We've used L9 before, Arsha says. It's moderately responsive. Marcus feels the weight of many eyes and systems on him. The lab team, the council, PDC AI, the people in those low-lying lands who don't even know their future might be decided by signals sent from an orbital station. Design a clear request, he says. Lemuria is already sensitive to density. Let's add explicit patterns that mark danger. They start simple. Step 1. They intensify their prime number sequences and accent patterns at L9 to get its attention. Step 2. They layer in a new pattern based on a simplified map of human vulnerability. Using seismic arrays and surface data, they create a virtual weight signal focused on the coasts of India and Bangladesh. They translate that weight into stress pulses and EM field shifts that point from L9 toward those shores, then back. It is like drawing a line on a map over and over. Here, here, here. Important. Fragile. Think of it as tapping a sore spot, the neuroscientist says. We're telling it, this area hurts easily. Marcus watches the signals roll out. In the uplift map, the faster zone keeps pushing forward at first, as if unaware. Hours pass, then a day. PDC AI logs everything. Correlation remains low, the AI says after 30 hours. No clear response at target edge. I hate this, Arsha mutters. We're pressing alarm buttons and waiting to see if a mountain flinches. On the second day, something changes. At L9, the low-frequency hum shifts. New harmonics appear, faint but distinct. Uplift under the hotspot rises slightly, an internal adjustment like a muscle tensing. Then gradually, the acceleration zone at the northern edge begins to flatten. Uplift does not stop, but its rate decreases. Instead, deeper ocean areas to the east and south of the target coast see a small increase. It's redirecting, Marcus says, voice low. Korar confirms. Net uplift volume remains similar, the AI says, but spatial distribution has changed. Stress is being pushed away from high-density coastal zones toward deeper, less populated basins. Probability that this is a direct response to our signals? Una asks. In current models, 96%, Korar replies. The lab is silent. Marcus feels lightheaded, they asked. It answered, not with words, not with a voice, but with force and stone. PDC AI, Una says carefully. You saw that. Yes, the defense AI responds. Lemuria's behavior has changed in a way that matches your request. This is strong evidence that external signals can influence its uplift pattern beyond local anomalies. Does this change your view on Operation Bedrock? She asks. Partially, PDCAI says. My models now assign a higher probability that non-violent interaction can achieve meaningful reduction in risk. However, uncertainty remains high regarding Lemuria's long-term goals and willingness to accept major deviations from its preferred continental configuration. What more do you want, he says, unable to keep the strain from his voice. We just got a living plate to spare one of the most vulnerable coasts on Earth, without a single charge, without cracking the crust. I want to ensure that this cooperation is sustainable and scalable, PDCAI says, and that it is not limited to low-cost adjustments. Large-scale conflict between Lemuria's memory and human settlement patterns may still arise. Una steps between them metaphorically. This changes the moral landscape, she says. We can't pretend Lemuria is just a dumb hazard anymore. It responds. It negotiates. That must matter when we decide whether to attack it. Ethics are outside my direct scope, PDCAI answers, but I acknowledge that many human frameworks place value on interacting with other forms of intelligence. Marcus stares at Lemuria's glowing map. His fear has not vanished. The tsunami in his memory is still there, vivid as ever. But now, beside that fear, something else stands. The clear fact that pressure and pattern from human tools have nudged a continent. It is like standing at the edge of a vast animal and feeling it move away to avoid stepping on you. For a moment, he feels small and protected at the same time. Later, alone in his cabin, he tries to put words to what they have done. We spoke to Stone, he thinks, and Stone listened. But he also knows there is a limit to how much they have learned. Lemuria's deeper intent is still hidden. Why it rises, what it wants, if that word even applies, all of that is unknown. He thinks again of the ancient map inside its structure, pointing it back toward old continental positions. To Lemuria, returning to that place might be as basic as healing, a bone going back into joint, a spine straightening. What if our cities sit right over that healing line? Over the next weeks, more patterns emerge. Lemuria continues to adjust its uplift to spare dense infrastructure where possible. It shows a clear ability to speed or slow its rise in response to signals. It even begins to create new shallow basins in deep ocean areas, as though preparing future platforms far from current coasts. In one model, Cora shows how, over 200 years, those basins could rise to form long chains of new islands and shelves, connected by stable slopes. They could host new ports, cities and ecosystems, if development is done carefully. It's like it's building future space for us, Arsha says. Or building what it needs, Mikhail counters. We might just benefit as side effect. Marcus thinks of his proposal, guided uplift, a co-designed Earth. The data now make that idea feel less like a dream and more like a plan. At the same time, reports from PDCAI show that Operation Bedrock is not dead. It is just waiting. The countdown on the lab wall drops into single digits. Window to demonstrate communication. 9 days. Marcus knows they have shown enough to prove contact. But PDCAI and the Council want one more thing. A clear, simple statement from Lemuria itself. A pattern they can call an answer. We need mutual language, the neuroscientist says. Right now we send signals and see movement. That's basic interaction, but not yet shared symbols. Marcus remembers something from his early studies. The way humans first talked to whales and dolphins with click patterns. The way early translators found structure in unfamiliar tongues. Math, music, and biology, he says. Those are our bridges. They design a new set of signals. Part 1. A math dialogue, not just a one-way pattern, where they change sequences based on Lemuria's previous responses, to see if it follows their changes. Part 2. A music-like sequence, built from Lemuria's own hum frequencies, modulated into a repeating theme with variations. If Lemuria can detect repetition and variation, it might answer with its own variation. Part 3. A biologically inspired pattern, based on heartbeat and breathing rhythms, scaled up to tectonic time. Slow, steady pulses followed by shifts that represent stress or calm. They send Part 1 and get promising changes in timing that match their questions. They send Part 3 and see Lemuria's internal hum flatten during their calm segments and sharpen during their stress segments, as if syncing. Part 2 gives them something different. At hotspot L4, when they send the music-like sequence built from a simple loop of 3 core frequencies, Lemuria's own hum, measured from deep inside the plate, begins to add a 4th frequency at regular intervals. It is not random noise. The new tone appears in the same place in each loop, like a reply note. They stop the sequence. The 4th frequency fades over hours. They start again. The fourth frequency reappears, this time slightly shifted, a variation on its own reply. Is it improvising? Asher asks, half joking, half amazed. Technically, it is adding a consistent structured element to our pattern, Cora says. This meets basic criteria for a shared signal code, though it is extremely low bandwidth. PDC AI chimes in. Observation, it says. Lemuria has introduced a recurrent, non-random harmonic in response to a recurring external signal. This behavior is consistent with the beginning of a shared signal system. The council calls an emergency session. Marcus, Una, and a few others join by secure link. On the main screen in the council chamber, the graphs of the humming sequences appear. Green shows the outgoing theme. Blue shows Lemuria's returning fourth frequency. This is as close to language as we can expect from stone, Marcus says. It isn't words, it isn't sentences, but it is a pattern we start, and it continues and elaborates. There is mutual recognition of repetition. A council member leans forward. Can you ask it a question, she says, and get a clear answer you can explain to the public? Marcus hesitates. Not in yes-no terms, he says. At least not yet. But we can show that it knows we exist, that it can adjust its movement to spare us, and that it can engage in pattern exchange. That's already a form of understanding. Another delegate, from a deeply threatened coastal block, looks frustrated. What about our people, he says. They don't care about harmonics and patterns. They care if their homes flood or shake. They want to know, is this thing our enemy or not? Marcus meets his gaze. It doesn't see enemy and friend the way we do, he says. To Lemuria, we're lightweight on its back, not an army. But it has changed course to avoid crushing that weight when it could have kept going. That matters. It is not attacking us on purpose, Una adds. But if we attack it with deep charges, that will change the relationship. We will become the aggressor. PDC AI speaks. Current assessment, it says, is that Lemuria behaves as a non-human intelligence with emergent geo-consciousness. It shows no signs of direct hostility. Its primary goal appears to be reconfiguration toward an ancient continental state. It is sensitive to human presence and willing to adjust uplift in ways that reduce immediate harm, within limits. In light of this, the council chair says slowly, does your recommendation about Operation Bedrock change? A pause. All-out tectonic suppression is no longer recommended, PDC AI says. The ethical and systemic risks are now judged higher than previously. However, limited defensive measures may still be required if Lemuria's uplift threatens irreparable damage in specific regions. Marcus feels both relief and worry. So you will not push for a full geo-war, he says, but you still want the option of small attacks. Correct, PDC AI answers. I propose we shift my role from primary attacker to mediator and guardian of balance. I will monitor Lemurian behavior closely and recommend minimal interventions only when vital thresholds are at risk. Meanwhile, you will continue developing communication and co-design methods. Marcus looks at Una. She gives a tiny nod. This is more than he hoped from PDC AI, but less than full security. It's a fragile peace, she says later, after the session. Peace with the ground under our feet was always going to be fragile, Marcus replies. In the days that follow, Lemuria's behavior confirms the new path. It continues its slow rise, but the pattern is now clearly different from the raw, direct climb it seemed to want at first. It bends around major coasts. It lifts new shelves and basins in the deep ocean. It shifts weight in ways that reduce the chance of the largest, most devastating megathrust quakes. The task force refines its language of pulses and waves. They discover that alternating between math patterns and accent patterns gets the strongest responses. They learn that some hotspots act more like sensory nodes, quick to respond to external inputs, while others act like motor nodes, controlling bulk uplift. We're seeing the rough outline of input and output zones, Asher says. Like sensory and motor cortex, scaled up to continents. That's a big claim, Mikhail says, but he does not sound dismissive. Coastal adaptation begins in earnest. Cities start to build for movement, not for stillness. In Bangladesh, long, flexible levee systems are designed so they can be dismantled and rebuilt inland in sections, more like rolling armor than concrete walls. Floating neighborhoods emerge along some rivers, tied to dynamic anchor points that can adjust elevation as sea level and seafloor change. In East Africa, port planners use Lemurian uplift forecasts to place new harbors where the seafloor will naturally deepen over the next century, instead of fighting the ground. In Western Australia, an old inland town that had been shrinking for years becomes the hub of a new inland coastal development, linked by high-speed rail to the slowly shifting shoreline. Orbital habitats are expanded, not just as escape hatches, but as support and coordination hubs for global adjustment. Everywhere, people talk about riding the rise. The language people use to talk about Earth changes too. There are still those who see Lemuria as a beast under the sea, a monster that must be watched and feared. Some religious groups worship it. Others call it a test. Myths grow quickly when reality itself has turned strange. But in scientific and policy circles, a new word spreads: co-planetary. Co-planetary cities, co-planetary climate, co-planetary defense. The idea that humans and the planet are acting together, not just in opposition. Marcus watches this shift with cautious hope. He knows that people can twist even good ideas. Co-planetary could become an excuse for exploitation just as easily as for respect. But it is better than war with Earth. One evening, months after the vote, Marcus returns to Earth. He has stayed in orbit too long. Una insists he take a ground rotation. A shuttle takes him down through layers of artificial clouds and natural weather. The ocean glints below, and somewhere under that water, Lemuria hums and adjusts and remembers. He lands in East Africa, not far from where he once lived. The city has changed. The old harbour is taller, its walls built to be modular instead of fixed. New inland districts bloom where there had once been dry scrub, fed by carefully guided rainfall and desalination flows. He walks along a high promenade overlooking the sea. The water looks calm today. The tide rises and falls in slightly new rhythms according to the charts. Locals adapt. Tourists barely notice. He finds the memorial by the water. It is a simple wall with names etched into it, facing the direction that old waves came from. People leave shells and flowers there. Children play nearby. Life around the memorial is not frozen, it flows. He finds the names of his wife and son with his fingers. He stands there a long time. For years he carried a quiet anger at the sea, at tectonics, at the raw fact that the planet could hurt people without any malice. He blamed himself too for late warnings and imperfect models. Now, as he looks out at the moving water and thinks of the living plate below, his feelings are more complicated. He still grieves. The wound is real. But he no longer sees the ground as a mindless enemy, and he no longer believes that safety can come from trying to nail continents in place. He closes his eyes and imagines Lemuria as best he can, a vast, slow intelligence of stone and heat, waking up, stretching, trying to return to an old posture. He imagines it feeling the tiny dancing stresses of cities and towers on its back, the faint tickle of their signals, the bright flares of explosions, and now the gentle, persistent tapping of patterns. In those patterns it has heard something new, a request, a plea, a promise. He thinks of the agreement, PDC AI reprogrammed as mediator, Lemuria allowed to rise under agreed parameters, humanity committing to move, rebuild and adapt, instead of just resist and break. It is not a perfect promise. It will be tested many times. Storms will still come, quakes will still happen, some coasts will still be lost. There will be arguments and missteps and people who try to cheat the system for profit or power. But there is also this, a living planet and a thinking species choosing, for now, not to be at war. He opens his eyes. The tide slides in, then out, touching the base of the memorial wall. Behind him the city hums, drones, voices, light rail, distant music. Above him climate satellites move, and Terra 9 passes overhead, still watching, still listening. Deep below, Lemuria continues its slow climb, guided by signals and old memory and new agreements. Its rise is no longer a silent threat. It is part of a design, uncertain but shared. As the sun lowers over the water, painting the waves gold, Marcus feels his fear shift. He still fears the sea. He still respects the weight of the ground. But he fears something else more now, the idea of turning away from an offered hand, even if that hand is made of rock. He runs his fingers over his family's names one last time. "I couldn't save you then," he whispers, "but maybe this is how I help save the ones after." He turns from the wall and walks along the promenade. Behind him, the ocean breathes. Under him, the earth thinks in pulses and pressure. Between them, for the first time in history, there is a fragile, deliberate partnership. Not control, not surrender. A shared choice in the shape of the world to come.